Hi, I'm Savis, and I'll talk about our work on Symbol Finder, an interactive tool for brainstorming diverse symbols using local semantic networks. Visual symbols are everywhere. They're used in public signs, user interfaces, and logos to convey important information. They effectively convey abstract ideas like misplaced and search with concrete objects, like an umbrella and a magnifying glass. Symbols are also the building blocks for visual metaphors, which are illustrations that combine symbols to convey complex meanings like police reform and contagious ideas. In order to be easily recognizable, a good symbol is simple and concrete in the content it depicts. It can either be a single object, multiple related objects, or an action. Currently, finding symbols for abstract concepts is hard for novice designers, and even more so when creating symbolic illustrations like visual metaphors, because they often symbolize concepts that are very abstract, like reform, and they require many diverse symbols per concept to overcome constraints in the design process. Popular publicly available tools don't make it easy to find many diverse symbols for a concept. For example, let's find symbols for control with Google Images. Searching for the concept as is leads to many irrelevant images from a video game. Users can also explore the suggestions above, and sometimes they're useful, like game, which we can click to find many symbols of controllers, but it's difficult to collect many different symbols from these suggestions because they often lead to very few good symbols. Finally, we might also search for control icons, which leads to a number of icons for control, and this is a good start. But still, these icons capture only one flavor of control, like sliders and buttons on an interface, while there are many more to explore. To understand the challenges novices face when finding symbols, we conducted a formative study, where we observed 5 novice graphic designers find symbols for 3 abstract concepts using Google Images. From our observations, we formed 3 design goals for Symbol Finder. 1. Help brainstorm related words to broaden their interpretation of the abstract concept. 2. Symbol diversity. These related words should be organized to convey many different associations of the concept. And 3. Concretize abstract concepts. Users should be able to explore concrete terms for each diverse association. From these design goals, we created Symbol Finder. Let's see it in action now. Symbol Finder consists of 2 phases. Here's the first phase for the concept control. Users browse a number of association clusters and select a few to explore further, like limit, restrain, restraint, car steer dashboard, and handle lever knob. Each cluster captures a different association of control. In phase 2, users dive into the clusters they chose and select symbols. Here the user selected the control regulate takeover cluster, selected the subterm regulate, then pressed the concrete term meter and collected a symbol of that. Next, they select the rule, governance, and government cluster, then press on the suburb rule and then the concrete term traffic light and collect a symbol of that. Then they open up government and find an image of the US Capitol building. They then select regulation and then press on the concrete subterm referee, where they find a symbol of a whistle and the referee. By exploring these clusters, they can find many different representations of the abstract concept they're symbolizing. Next, I'll very briefly go over the implementation of Symbol Finder. To create the set of diverse associations we show users, we first generate a local semantic network from the root concept using the small world of words word association dataset. From the root concept's control, we add words to the network that are associated to it in the word association dataset. We create 2 levels of words in the network to create a large set of closely related associations. To separate these associations into a set of diverse ideas, we cluster the semantic network using the Louvain community detection algorithm, which identifies groups of densely connected words. Finally, we sort the words in each cluster by concreteness to bring more imageable associations like king, jail, and kneel to the top of each cluster. Now we have a set of diverse associations we can collect concrete terms from to symbolize control. To evaluate Symbol Finder, we compare it to Google Images and answer the following questions. 1. Unique symbols. Does Symbol Finder help novice graphic designers find more unique symbols than Google Images? And 2. Perceived difficulty. Is finding symbols with Symbol Finder less difficult than with Google Images? To answer these questions, we recruited 10 students from a local university. who used both Symbol Finder and Google to find symbols for 6 abstract concepts, 3 for each system. To answer our first question, users found significantly more symbols with Symbol Finder. On average, Symbol Finder users collected 14.8 symbols per concept, while Google users collected 9.92. We ran a paired sample Wilcoxon test and found this difference to be statistically significant. Symbol Finder encouraged multifaceted interpretation of each concept, which helped participants find more symbols. Here are a few results. These images are for the concept control, where the Symbol Finder user found symbols from a variety of contexts, including government, voice control, signage, control input devices, and more. Here are also some results for fast, where we see a similar effect. And finally, here are results for dangerous. Once again, this user found almost double the number of symbols compared to the Google user. Next, to answer our second question on perceived difficulty, Symbol Finder required significantly less mental demand and effort. Participants often hit dead ends of redundant symbols with Google, and they would often rely on their own brainstorming to find more symbols, increasing their mental demand and effort. As well as comparing to Google, we also conducted a case study to understand how Symbol Finder helps novice designers in practice. We deployed the system to a group of 3 students who make cover illustrations, often visual metaphors, for a university science publication. We observed them in 3 sessions as they made cover illustrations for 3 news articles. For the 3 articles, the team made a total of 32 lo-fi prototypes, which they then iterated over to create 6 high-fidelity prototypes shown on the right. Here are some of the findings on their process. When picking concepts to visualize in each visual metaphor, the team would often pick at least one abstract concept to symbolize, like neurology, reform, and participation. When picking symbols, they focused on finding as many different representations as they could for each concept, without paying much attention to the style of the image. Afterwards, they would ideate combinations of symbols from each concept. Symbol Finder helped the team find many diverse symbols per concept, which in turn helped them to create a diverse set of prototypes to show their client. Looking towards the future, there are a few things that can greatly improve Symbol Finder. Symbol Finder is currently limited to its word association dataset. During the case study, the designers wanted to explore symbols for COVID-19, which wasn't in the dataset, so they brainstormed on their own and inputted related terms into Symbol Finder, like virus. In the future, we could use frequently updated knowledge bases, like Wikipedia, to extract keywords and add new concepts to the dataset. Another area of improvement is in helping users find the perfect image with Symbol Finder. Currently, Symbol Finder helps users brainstorm many diverse representations of a concept, but does not help them fulfill their other constraints when searching. The graphic designers in the case study would often perform a secondary search on Google to find an image with a particular background, color, one that was free to use, and more. Now looking more broadly at brainstorming tools, we believe that word association datasets like Small World of Words are better suited for expanding and relating ideas in brainstorming tasks. These association datasets are more closely aligned to people's mental perception of words and lead to related words that are more relevant and concrete. Finally, concreteness can also be applied to many other brainstorming tasks. We can use it to evaluate and convert vague ideas into more specific and concrete ones. With that, I'd like to say thanks for listening, and please check out the paper for more details.